In the name of merciful and compassion of God, in continuous of video 1, according to tutorial and course safety, electrical safety in industrial, oil industrial, commercial centers, I continue here with the lessons and items, distribution systems, kinds of distribution systems. After substation, after the step-down transformer pulse. These distribution kinds system after a stop or delta doesn't make any difference. A step down transformer, R S I T T N C T N S and T N C S and also T T. First, I have to describe and explain for you what's mean of the letters over here. The letters over here, first I describe and explain for you first letter. If the first letter was T, it means we have earth speed in transformer post and we use it. But if the first letter was I, it means we don't use the earth's speed or earth's electrode post transformer. The first, it was I, we don't use, T, we use and we have. Also, the second letter, it was N. It means we joined all of the metal parts of our installation, our factories, our buildings, our refinery, join our metals to the RB, the earth speed was N. But if the second letter was T, it means we don't use of RB of the poles. We have separate earth speed in our installation and industry. Private earth speed electrode. That's the second was explained of second letters. The third letters, it was C, it means we have PE, protective earth wire, and N, neutral wire together. We use both of them together, join together as result be pen. N, C, and it was S, it means that was joined. If the third letter was C, we have pen. If the third letter was S, it means we separate both of that, PE. And neutron are separated and isolated from each other. That was to explain means of the letters distribution, kinds of distribution system. Right now, we're going to explain this distribution system one by one. First, T and S. We explain T and S. You know, the star after the post, we have a step down, transformer, a step down, a star, or delta. Most of the time, a star, because when we have a star, it is easy for us to make a two voltage, phase voltage, and line voltage. In a star, line voltage equal phase voltage times 1.73, 3 radicals. Radicals 3. For example, in Iran, line voltage 380. Phase voltage will be 380 divided to 1.3 equal 220 volts. In United States, phase voltage equal 120 times 1.73 equal 208 volts. I think close to this. Yes, 280. And also in a star connection, current phase and line phase is equal. In delta connection, line voltage equal to phase voltage, inverse of that connection. In United States, they use many taps in step down. The many tap, they can use many voltage, 115, 108, and also they in step down secondary, they use delta or a star. Okay, that was briefly talking about the step down transformer in post transformer or substation transmission. First 230 kilowatt, 130 kilowatt, 63 kilowatt, 20 kilowatt, then change it to 380 volt. Here we have 380 volt line to line and 220 phase voltage 300, and here 220 in Iran, and some country in Europe. Okay, first we want to talk about T and C. Okay, T, we have RV, repeating post. We have L1, L2, L1, L2, L3. C, we have a pen, because protective earth and neutron are joined together, not separate. We have pen. And here we distribute a single phase and or three phase distributed box. This is TNS system. We have phase voltage from one of the line to pen, and line voltage one of the L1 between L2, L3, L2. Over here, they are the metals. This means metals, body, like body of the all electron outers, compressor, some devices, and also metal of the foundation of building, rod, and also pipe we use here. In TNS, TNS also we can separate earth from here too. Separate earth to the all devices, and this is neutron, neutron, and this earth. That was schematic and diagram of the system distribution T and C. Okay, after this we're going to describe T and S, other distributed system. This system is underground system. Underground system right now is favored and most popular for distributed in across the air distributed, fire distributed. Okay, T and S. We have a stop, a step down. T, we have RV. And we use it. When we have second letter N, we use of this RV, or P. S, separate PE from neutron. Neutron, PE, L1, L2, L3. Single phase and three phase. No neutron and line voltage Here is all the metal bodies as foundation pile building, foundation rod. Every metal we want to use it. Pipe of water pipe, water gas, pipe gas. We can join all of these. TNS. TNS. Over here we have joined all of the metal and as pipe, rod, metal, and also body of our devices. That was TNS. TNS is a famous and very popular in Europe under grinding, and they use PE, protective E, from shield of cable, metal shield of cable. Metal shield of cable, they will use metal shield of cable as a PE. Is underground system. Okay, going to introduce TT. We have RBT. Second, we don't use of that. Because we ourselves make earth pit for ourselves, our factory, our industrial, our building. We have private earth pit. We have a private earth pit separate of RV, post RV. This book, that is my book, which in Iran I publish it. All of my experience, I author of this book and teaching in centers of TVTU and universities sometimes. Over here we TT, explain TT to you. Is that is TT. The TT system is not underground. This system is air pile distributed system with a pile and air came from to customer from air, not underground. Okay, going to other system, IT. Sorry, IT. IT system. We have both over here. The first letter is IT. IT. We don't have RB, post P, post LP. Over here, we have Z. We don't use of this. Single. This, actually, the singular over here looks like two-phase. We don't have neutral. Over here, we made T, the system T. We made by ourselves RT. This is for mineral. This installation, use it in that place. We don't like after the faulting in our systems, don't act the fuses like cinema, theater, mineral place. The mineral place, if you cut out the fuses, maybe the stairs, the elevator cut and is dangerous for person. We use of this. We use arm in the case of short circuit. For example, we have a light over here and one phase to the light, other phase to the ground. If one electrode of the light go to the earth and one phase we join to the body of the body of our devices, take to wire into the lamp. If there are devices short circuit to the body of the our electromotors, this light will be turned on, light on, and or alarm. They alarm it or hold it to alarm us, understanding the fault are in our system. Then we when alarmed by hole or buzzer or the light, then we go to the fix it. But we don't like in this system, as I described it in the protective circuit in video 1, how the IA of fuse was equal IN times coefficient, for example 3.5, 2.5, and immediately after faulting, the fuses must act and cut out our circuit. In here we don't want immediately the fuse to cut out. We want to stay warm to, because we have the condition, bad condition for person, or we don't want to playing cinema, playing theater, that people are watching watching the film. We don't like to cut out the fuse. Okay, we have A common system TNCS. TNCS, it looks like TNC with this different. We use most multiple body. More foundation, more metal device, devices to doping it or power it our system, because in here in Verse IIT we want our fuses immediately faster and very fast cut out. Yeah, it looks like TNC pen, L1, L2, L3. Showing neutral, phase, and more than the TNC we use the multiple metal as a case of our devices, or pipe, water pipe, gas pipe, everything we join it to the body and join it to the pen. For take a less ohmic in our installation. For what reason? When we have a less ohmic, we can faster and faster cut out the fuses. That was all of the distribution system in the world we use. It doesn't make any difference. Asia, Europe, Africa, every place. I have two noted to you for the here we don't have in our systems, here we don't have to have capacitance property. It's bad for our systems. How can to delete and call off the capacitance system property? Because the capacitance system property make a potential over here to over here. Is made a potential between pen and RB. It's dangerous, especially in refinery, oil industrial, because that make a spark in sometimes, and a spark and explosion in some place which we have gas, dangerous gas. For delete and call off that, we have to pay attention to insulation code. Insulation code must be a standard. The standard insulation code. We have a rule over here. You should take measurement. RISO is mean resistance of insulation cable equal RISO equal U systems divided 1 milliampere, for example, 220 volt, divided 1 milliampere equal 220,000 ohms. You should have 220,000 ohms, 220 kilo ohms insulation in 220 volts distributed system. 380 1 milliampere is limit leakage of insulation cable. Limit in the leakage current from insulation of cable. Maximum is 1 milliampere. More than this is not limited. Is not permitted to do it, to have it in your installation. And this is 380,000 or 300 kilo ohmic for 3 phases. 4 phases. The 4 phases, you have to have more and most in ohmic insulation than the earth and neutral and protective air insulation. Protective air insulation 220 kilo, but the phase is 380 kilo. You should measure it by Megger tester. Megger tester and earth tester I described before for you are the same structure, the same phase, but it's very different. The air tester show you the less ohmic for RV, because all here RV, in RV we want maximum 2 ohms, 5 ohms, but we tested with air tester. With a Megger, we test many high ohmic as a 380 ohms. Over here I have one easy. If it is expensive for you, because here expensive, the devices is very expensive, I made one circuit. After searching, I made one circuit, very easy circuit to find out your insulation ohmic. Over here you put a battery, 24 volt battery. You serve it, and here you put a RA wire or brake resistance. Wire or brake resistance. Over here, ampere meter, and here your insulation or ISO. Then I find that the equation R ISO equal U system, U here, this U 24 divided ISO here minus RA. With this simple circuit, you made a Megger, which the Megger is device is very expensive. Okay, thank you very much. I'm Behruz Ahmed from TVTU, Iranian, and work in Tehran. Thank you for watching our tutorial about safety, electrical, in industrial, refinery, building, commercial. In future video, I hope to have a tutorial and educated and teaching what substation, circuit breakers, and also progressives, advanced relays, and also driver, and many items of electrical power feed. I thank you.